Imagine a motor that harnesses the raw power of magnetic repulsion to generate clean, efficient torque. That's the compressed inverted magnetic energy source, or CIMES, from U.S. Patent 11799-400B2. But some skeptics call it a perpetual motion machine, a device that supposedly runs forever without input, defying physics. Today, we're diving into the science to quash that narrative once and for all. CIMES isn't magic. It's innovative engineering grounded in real physics. Let's break it down. CIMES is a rotary motor designed by inventor Dan Buck. At its core, a fixed stator with inward-facing magnets, all north poles exposed, and a spinning rotor with outward-facing north poles. A central shaft connects to the rotor, and a compression plate pushes the rotor closer to the stator. Here's how it starts. An external motor gives the rotor an initial spin. Then, compression is applied. Think of it as squeezing the system axially. This brings the like-poled magnets closer, amplifying their repulsion according to the inverse square law. Force increases dramatically as distance decreases. The repulsion isn't uniform. Magnets are spaced irregularly to minimize counterforces. A flywheel on the shaft stores angular momentum, smoothing out the rotation. At the tip, axial magnets provide lift, reducing friction like magnetic bearings. The result? Net torque that drives the shaft, which can power a generator for electricity. Why do people think CIMES is perpetual motion? Magnets seem like free energy. They repel without fuel. But perpetual motion machines claim to create energy from nothing, violating the first law of thermodynamics, energy conservation. Or they ignore the second law, where entropy increases, making perfect efficiency impossible. History is littered with debunked ideas, from Leonardo da Vinci's unbalanced wheels to modern magnetic ramps. They all fail because friction, air resistance, and heat losses drain energy. No machine runs forever without input. CIMES gets lumped in because it uses permanent magnets, but that's a misunderstanding. Let's prove it wrong with science. First, energy input is required. Compression doesn't happen for free. It takes mechanical work, often from a motor or lever, to overcome the magnet's natural repulsion and position the rotor. That's your startup energy. The core force is magnetic repulsion. Femag equals the permeability of free space times the product of magnetic moments, divided by 4p times distance squared. As compression reduces R, Femag skyrockets, creating torque T by R times Femag times synth, where Th is the angle between force and radius. But this isn't creating energy, it's converting stored magnetic potential from compression into kinetic rotation, like a spring uncoiling. Newton's third law applies. Every repulsion has an equal reaction, but the system isn't closed-loop infinite. Friction? Minimized with ball bearings and axial magnetic lift, but not zero. Over time, eddy currents, air drag, and minor misalignments cause losses. Without occasional recompression or maintenance, it slows down. No overunity. Output never exceeds input. Tests would show efficiency under 100%, compliant with thermodynamics. CIMES is an energy converter, not a creator. So, if it's not perpetual, why bother? Because CIMES has massive potential based on solid science. Unlike traditional electric motors with coils and high energy loss, CIMES uses passive magnets for repulsion, slashing friction and heat. It could boost efficiency in electric vehicles, extending battery life by 20–30% through onboard generation. In renewables, pair it with wind or solar for hybrid systems that store momentum via the flywheel. For homes, a washing machine-sized unit could generate 1 to 3 kWh, cutting bills and enabling grid sellback. Industrially, it powers pumps, robotics, and aerospace with reliable torque. Backed by physics like Coulomb's law and angular momentum conservation, CIMES could transform energy sectors, reducing fossil fuel reliance and emissions. It's not defying laws, it's optimizing them. Simulations and tools like CIMES or FEM can validate this, paving the way for prototypes.